Hi, and welcome to Lecture 5 of COSI 5785. Today we're going to talk more about finite state automata. Recall from last time that we started looking at these finite state automata, which we draw as shown here. Here's another example of a finite state automaton. It has 3 states and 4 transitions. And what I want to illustrate here is what happens when there's a failure. So in other words, what happens when a string is not accepted by an automaton. But let's begin with this example. In this example, you see that we started in the start state and we scanned the quote, which moved us into the middle state there. And then we found this other quote, and that moved us into the final state. However, we're not finished with the string. And from the final state, there are no transitions anywhere. So therefore, the automaton does not accept this string. Okay? With the same automaton, let's look at this example. Start in the start state, scan the quote, move to the middle state, move the pointer to the character A. A, B, and C get eaten, if you will, by the automaton. However, at the end of the string, we're not in an accepting state, and so once again, the automaton rejects this string. So in other words, none of the strings that I've given here as examples so far today are in the languages of the automatons that I've used in my examples. Okay, well let's get hairier here. Let's look at some more complex automata. Here's an example of one that's more complex. Notice that there are multiple transitions defined here on 0 and 1. So if you're in the start state and you have a 0, you can either go up to that state to the top left, or you can stay in the start state. Similarly, for 1, there are 2 states that you can go to. So basically what this means is that the automaton goes into multiple states at the same time. So when it's presented with a 0 in the start state, it goes into both states 0 and 1. So looking at an example then, starting with the 0 in the start state, after scanning the 0, we move into the start state and the second state shown there, and we move over the 0. In this pair of states, if we get a 1, what state should we go to? Well, if you look at the start state, a 1, we can go back to the start state. If you look at the other state, with a 1, we go to the next state to the right, and so we should be in this state. There's actually 3. I made a mistake there, right? So there's actually, you can actually go stay in the start state, or go to either of the other 2 states that are shown in the diagram, and then we move the pointer forward. So now in this state, what do we do in these states, I guess I should say, what do we do when we encounter a 1? Well, one of those states dies because there is no 1 transition out of it, but there's still 1 transitions out of the start state, so there we go to both the start state and that next state. And we continue this process until we finish the string, or there's no more moves that can be made. And at the end, if any of the states that we're in is an accepting state, then the string is accepted. So since we are in at least one accepting state here, the string is accepted. Well, we can build more and more complex automatons. I won't get too carried away here, but here's one more example where you see for the first time us labeling arcs with epsilon, or the E transition. And what this means is that these transitions are followed automatically without consuming any input. So basically, as soon as we go to the start state here, we're going to go simultaneously to all three of those other states that are reachable by E transitions from the start state. So if we look at an example, we start with a B. So when we go to the start state, we immediately go to all of those states. Okay, and so now we do the same process that we did before. In any of those states where a B is accepted, we take the transition for that, and then we keep moving along here. But notice that some of these paths, if you will, are dying because there is no transition out of that state given what the current input symbol is. And we keep going along here until we get here, and we see that this automaton actually accepts this string. Okay, that's all for this lecture. See you next time.